boys. Today I'm gonna talk about physics-based character controllers. So let's just say you're making Half-Life 3 and you want your character to be able to push physics-based boxes and maybe pick something up or get affected by physics-based boxes. So what you would probably do is creating some kind of system with a very non-physics based character controller, and then make it interact with those physics-based objects. But we're going to do things a little bit differently today. I'm going to show you how you can make a character that is completely based on a physics engine and that it interacts with physics-based objects naturally. So yeah. Okay. We're going to create a new project for this. Oh, no. So, yeah, sure, whatever. So, let's create a new project called yeah. This is unrelated. Okay, fine. Okay. Alright, so, first of all, I'm not actually that amazing of a programmer as, let's say, Kindex. So, I'm gonna show some programming, but please don't be hard on me if you see me programming shitcode. But mostly I just want to show some kind of concept of how to do things when you want to make a physics-based controller. So let's start by, well, actually, I like to organize my stuff, so up. Yeah. So I'm gonna make a little material called ground and a material called box. So I'm gonna make a little scene so when we would move around in character we would actually see what's going on. Because we're gonna be, I think we're gonna be doing things in first person. I think, maybe, I don't know. So let's create, actually no, whatever. Let's create a cube instead, and let's make ground. Let's 16 by 16, and a little box. Actually, let's make it smaller. Alright, I see this this scene has some slowdown, but whatever. And let's also yeah, that'll do. Okay, so we would have our camera here, and if we would move the camera inside of the scene, you would actually see some geometry. Okay, so this will be our little test scene that we will be testing things in. So let's create I guess a capsule, and let's move it to a desirable location, such as, yeah, that will do just fine. And let's see, the thing is, you would probably want your character controller to be a capsule, and if you would make your character controller a box, for example, it would have some weird collision problems probably. And what you want is to have a physics-based object that you would attach your camera to if you want a first-person controller, which is what we will be doing. So for example, if we made this capsule physics-based by adding a rigid body component to it, you would see this capsule just falling down and flapping over like a fish. And we would probably want it to be falling down like that. So actually, one of the things the first things that you probably want to do is to well, actually, you probably want your camera to be attached to it. No, that's not 9. No, no. Yes, no. Yes. So if we would then maybe rotate the character a bit, you would see that the camera would be like, that actually looks like a dying animation or something. But that's actually one of the benefits of using a completely physics-based character controller, is that you can actually simulate little death things like that. So let's call this player, and the first thing is that we probably want to do with the body itself is make it heavier and restrict it from falling over. And to do that, we can actually just freeze its rotation completely. So these the rotation of the object won't be affected by the physics engine. So if it fall over like this, you would actually see that it actually stays like that. So if you would remove a little checkbox like that, you would actually see it fall over. So we want it to be straight. And now I suppose we can start scripting something. So let's create a little script called game camera. Oh my god, I hope Visual Studio works here. Well, while we're at it, I guess we can create another script called... Wait, we can't do anything. Okay, never mind. While it's loading, maybe someone has some questions? Please talk to me. Hey man. No? Okay. Guys, my muscles killers. Muscles killers. Is Visual Studio started? Actually, no, let's just... well, what? Ah, that's the code project. No. Oh yeah, one of the things that I'm gonna do before anything is I'm going to disable some lighting features so things work a bit faster. Okay, so yay. Okay, so what we probably want for a camera is a few variables such as actually no, it doesn't have to be public. Actually, it does. So we're going to call it rotation and actually no. Sorry. We actually want two float variables for looking up and down and looking left and right. So there's going to be pitch and jaw. Pitch is basically looking up and down, and jaw is looking left and right. So in late update, because we want to do this after the update, we want to apply a rotation, and we want to, in update, we want to modify our defined rotation variable, and we're gonna define it like this. I'm gonna create a new quaternion rotation thingamajig by using a vector. So I'm gonna call an Euler function and say we want to use pitch for up and down, we want to use jaw for left and right, and we don't want to roll. Actually, let's make roll as well. Roll is basically exactly what it sounds. It will allow us to make the camera roll, which is not exactly what we want, but we can use that as well. So let's make it possible to actually rotate the camera with our mouse. So we're just gonna modify the let's say jaw variable is actually pluses input dot get axis. Let's get axis of our mouse, and Unity has a built-in input array of classes that contains some input stuff, and the mouse X is one of those. It's basically the horizontal speed of your mouse. And let's make a variable called mouse speed. It's gonna be like 200, let's say. And let's make the exact same thing for moving up and down. And it's gonna be minus. Oh wait, actually no, we have to multiply it by delta time, because we want the camera movement to work properly regardless of the frame rate. So now let's hope we don't have any errors. If we attach the script to the camera, we should be able to move around our mouse and look up and down. Yep, works. Yay! So wait, the lighting did weird. Whoa. Ah, okay. Yeah. And to make things a bit nicer, let's make it so that if we start the game on awake, we probably want to make our cursor invisible, and we want what? Oh, we want our cursor to be lock state is no. want to lock our mouse. And now if we start the game, you can actually see that we don't have any mouse now. You can move our mouse, we can move our camera however you like. But if we press escape, our mouse kind of escapes, sort of. But not really. Okay, this is weird. Okay. So, well, actually, let's make it so that if we press escape, then and let's make it so that we can only move the camera if the cursor is invisible. So if cursor is visible, then only, oh no, if it's not visible, only then we can actually move the camera. And then if we press escape, does this work? Then we would set mouse visible to true, and we would unlock the mouse. So now if we move around our mouse, everything works. If you press escape, the camera stops and we can pause the game or something. Okay, so that's some really basic stuff. Well, actually, we could do more with this. Like, for example, we can actually look down and we can like look like this, which is weird. That's probably not what we want, but that's a thing. And keep doing that. But I guess we'll leave that to later if we have some time left, because that's some extra stuff that we don't have to worry about right now. So I guess that's enough for the mouse camera movement. Let's make a new script called player or something. Yeah, it's gonna be sure. Wait, what? Okay. Okay, so what we need for the player is we need the player script to be able to define the rigid body component. And to do that, we're going to create a private rigid body variable called body. And upon awake, as in when the game starts, we're going to find such a component. And yeah, and after that we're gonna just do something with it. When you're doing things with physics, it's often a good idea to do things in fixed update, but I'm a crazy man, so I'm gonna do stuff in regular update too. Don't ask. So let's create some controls. So for example, if we press no, actually, no, what? Never mind. Let's create a new variable called private vector2 input act2d, and let's use this input2d to create a new vector that will take into account. Okay, never mind. If so, let's create horizontal speed. Horizontal input is going to be bottom. Okay, never mind. I'm sorry. I just realized that Unity actually has also a built-in. I remembered that Unity has a built-in input for VAST and the cursor keys. So all we really need to do is just make a new vector2d that is going to contain input.getAxis. I think it was simply horizontal, and then let's make another one called vertical. So what we're gonna do is we're gonna get the body body the rigid body's velocity, and let's create a new vector called, no, actually, know what? Let's just give it our own velocity. And the new velocity is going to be way better because we can define it by ourselves. And it's going to be new vector 3, and it's going to be input 2d.x, and it's going to be body.velocity y, because we want to keep our vertical, our up and down velocity the way it is, because we want a rigid body to still use gravity and do other things with that. So velocity.y, and it's going to be input 2d.y, regular y, not capital Y. And then we just apply our new velocity to the rigid body velocity, and magic happens. So if you run the game, we can press VAST, and we can kind of move around, and we kind of have physics, and come on, yay, we have gravity too. So let's but there's one problem. Aside from that, we're moving at a snail's pace. If we turn around, we still move like forward. So we need to take the camera's direction into account. So what we're going to do is we're going to create a new quaternion called facing direction, and it's going to be another Euler, but the thing is, we're gonna only use the y-axis, and it's gonna be used. We're just gonna take the camera transform Euler angles y. Basically, we're just gonna take the main camera's y rotation, or jaw, and we're going to use that, and we're going to multiply it with our input velocity. And yeah, actually, you know what? Let's just to make things a little bit stable, let's just add this. Because so it's not affected by the so the gravity isn't affected by the facing direction at all. I'm not sure that will change anything, but that might cause some problems later on. So now if we press forward, we actually move forward exactly where we're facing, and we can move around. So let's make a new variable called private. No, actually, now it's going to be a public speed, and speed is going to be maybe 5, and we're just going to multiply. We're going to multiply our input by speed, and that will actually make us move faster. Hopefully. Yep, yes it does. And the cool thing about all of this is that everything, the movement and whatever, is completely affected by the physics engine, because our character controller has friction, and the friction takes care of literally friction. We don't have to manually lower the movement speed of the character or anything. If we move in the air, we move much more freely, and everything's awesome. And also, if we create, let's say, a box, and call it interactive box, we're gonna give it a different material to differentiate it from the red box. make it green. Then if we make a box like this, for example, and give it a... Actually, let's still make it big. And make it like really heavy, like 2000... Let's give it 200 kilograms or something. Then if we go ahead and push it, we can actually literally push it. And this is nothing like scripted or anything. This is literally just a physics engine doing its job. And yeah, we can actually... Another thing that you probably want to do is to give the character some interpolation, because eventually you're gonna run into the problem where if you're gonna move around, you're gonna see the whole screen will be like lagging behind or something. So we probably want to use interpolation for this. So anyway, I guess the next best thing to do is to make it so that we can perhaps move in different speeds. So let's say walk and run. So walk would be 2, run would be 5. So if we pressed and then we probably would have like a private float, private bool for walk, and then we would then tell the game that walking is enabled or disabled if we press for example, what's your favorite crouch button? Control or C? Yes. Okay, so then if we would, for example, well, here we handle all the input, and here we would handle like velocity stuff. Here we would handle like or something. Then if we would call it walk, if we would walk, then speed would be speed walk. And then if instead of walking, we would probably run. So then we would run. So now if we move around and we press shift, we run faster. If we release shift, we move slower. Or not. Oh wait. Oh Jesus. Why crouch? What? Oh wait. What? Yeah. Works. Yay! So, well, I guess we have to make crouching now. And let's make another speed variable for like crouching. And let's make it 1, so it's slower than walking. And so let's okay, let's appease everyone. So let's make it so that if we crouch, then speed is speed crouch. But we can't crouch and walk or run at the same time, so if we're not crouching, then we can walk and run. But there was one thing left. When we crouch, you probably want to move the camera down. So we're gonna make these public, but we don't want to see them, so let's hide them in the inspector. We don't want to see them in the editor, probably. Or maybe we do for debugging purposes, but we don't care about that now because that's boring. So yes, fine. So yeah, I'm gonna do a little quick and dirty hack to do this, but let's make it so that we have like a private float for height. Actually, height's gonna be like 0.75. I think. Okay, and in late update we're gonna be, let's say, local position. We want local position because we want position relative to the character object. So this is gonna be a new vector, and we're gonna totally ignore the sides. We don't want our character to lean or anything. We're not making Thief or Deus Ex, although I would want to. And let's just make it so that we use the height. So when you apply the height, we're gonna height is, well, actually no. Okay. How do you find a player? Well, there's only one way. Well, there are actually many ways to do this, but one of the ways is if we would make a variable here called public player, but that's boring. We probably would want other things to use player as well, like the enemies or the police or something. I don't know. So let's make a new script called. Oh, this is actually how I kind of do it myself, and some other people do it like as well. So let's say game logical or whatever. Let's make a class that is completely static. Actually, this class should be static because we probably want game logic to have some other things too. But let's give it a static variable called public static player. Yeah. And then when the player is created, we would want it to be like game logic that player is, well, this is the player, and in here we would want to say hi if game logic dot player dot crouch, then let's make the height smaller or something. My God, seriously? Where's search? Where is it? Keyboard? No. What? Tabs. Where's tabs? Text editor. General. Oh, there it is. And keep tabs. Yes. What? It doesn't? Oh! Yeah. Okay. So else we want the height to be 0.75. So now, if we run the game, hopefully it's gonna work. If we crouch, you can see that the camera goes lower. Yay, but this looks awful because there's no transition. So let's make a transition. Okay, this is what I was saying with quick and dirty. This is kind of an okayish way to do it, but not necessarily the best way to do it. But what you can do is you can make height a math function or math float. You can lerp it from itself to 0.1, and then maybe let's say use 10 delta time. Delta time. And let's do the same thing when standing up. So now, when we crouch, we have this. Yay! Looks that surprisingly works well, kinda. Okay. Well, I suppose a lot of people wouldn't know what I just did. Basically, lerp is linear interpolation. So I interpolate this this variable from one position to another. So let's say I would say, for example, if this was 0 and this was 1, then this third variable would determine how far in between this original variable is between those two defined variables. So in this case, I actually just told it to find the like something in between itself and something else every single frame. So it starts out going to its targets fast, but then when it gets closer, it moves slower. So it kind of creates a smooth motion. It's not the best way to do it, but it works fine. So whatever. I guess the next thing that we could do is add some jumping. I guess. So let's make a variable called grounded. So when we grounded would basically mean if the character is on the ground or not, and by default, I guess it's gonna be true for now. So let's just say that if we would get key down, we would just press a space bar, then we would attempt to jump. And that's how you make a jumping in the game. Actually, I'm lying. You need to make the jump function too. So, if we would to run this right now, nothing would really happen because it would call this function and that's it. But for now, let's just say body dot, and actually no, let's just say velocity. No, actually body dot velocity. Our physics rigid body velocity should be overridden, and you know we would actually add some extra height to it or something, and it would actually push the character upwards. But we make a new vector for now because we can't directly. Actually, maybe we can. Can you do that? No, I can't. We need to make a new vector and then apply to body.velocity. And we're gonna do that by creating a new variable called jumpVel. And this jumpVel is gonna be vector3 jumpVel is basically the same body velocity, but we're gonna modify its y value to jump height, which then we can define, for example, if we or speed. Okay, let's say 10. So now if we run the game, press space, we can jump really high. Whee! But we can actually jump multiple times. So that's not cool, I guess. What we can do is we can actually check for the ground in many different ways. But a really quick way of doing so is with a raycast. A better way would be to use a spherecast, but that's going to be a little bit more complicated, and if you want to get into this, you probably would figure it out. But we'll just use a raycast for now. And the way we'll do it is we want to do that in finally something in fixed frame, a fixed object. So let's just say grounded is we're grounded if we're gonna get the raycast to collide with something, and we're gonna make it collide with the ground. So if it collides with the ground, then we're grounded. If not, then not. So let's just call a raycast. Does anyone know what raycast is? No? Okay. It's basically just a line, and and if it intersects with something, then it returns if it does, or some information about what it collided with. So you can like make a raycast for bullets, for example. So you can make hit scan enemies, which please don't make hit scan enemies. Hit scan enemies are awful. So let's start it out from transform.position, and let's shoot it downwards, which would be just minus up, and we want it to be we want a layer mask, actually, probably, because we don't want the raycast to be colliding with the player itself. So let's make a layer mask called ground layer, and let's also make the length of it. So we define the length of it, then the ground layer, and yeah, that should be just fine. We want it to be just about a little bit longer than the player itself. I mean, at least half of it, because we're shooting the raycast from the middle of the player. I think that's how it works. I'm not sure. Okay, we have some variables here, but we probably would want to differentiate these, because like there's speed and then there's jump height. Nice way to do it would be, there's actually two nice ways to do it. One would be to make a class, which then would make like a drop-down menu or something. Or you can you could also do the exact same thing by making your own editor, which we're not going to do here. But a really quick way to do it would be to create a header attribute called jumping, for example, and speeds. So now in the editor you could actually see like some small header texts in bold that would tell us what is what. So now we need actually to check what is ground, and I guess the ground would be default. And let's make a new layer for characters. And let's make the player a character. And the thing is, we don't want the player to be checking for ground on characters, so we just don't make it to look for characters at all. Okay, so I suppose now we have the grounded variable, and we can check we can check it so that you can only jump if we're grounded. Well, one of the ways would be doing it like this, but we can actually just cancel out the entire function if we're not grounded. So now if we press play, we jump, and we can jump multiple times. Yay! So that's a really easy way to do it. Well, I suppose we can fix this problem now. I don't know how much time I have left, actually, because I was thinking about an hour. But I suppose we can quickly fix that as well. Clamp rotation, rather clamp pitch. So let's see if we rotate the camera by its pitch, then it shouldn't be larger than 90 and shouldn't be smaller than -90. So if pitch is larger by 90, then pitch is 90. Nah. Actually, you can really clamp it, but But maybe you would want it to play like a sound effect if you would hit the end or something. Well, clamping actually can cause some problems because it doesn't just it doesn't stop the movement or anything. It doesn't stop anything. It just locks the value. So now we can look up and down completely. Uh, some games like to let you look up and down a bit more than 90 degrees. I think Unreal Tournament 2003 let you do that, but yeah. So now we can crouch. We can crouch midair like in Half-Life maybe. Well, actually, one of the things what we can do is making crouch good for something. So if we crouch down, you can actually see that our shadow doesn't change at all. So what's the point? Actually, we really can change it. We can change our size actually. So let's make a new variable called height, and in late update, let's change our scale to actually height should be 1 by default. So now, for example, let's say if we're crouched, then height is 1.0, and if not, then height is 1. Whoops. Oh. So you can kind of see that we get smaller, but this is actually not. I didn't actually take into account the fact that if you just yeah. For some reason that reminds me of Battletoads. I don't know why. Oh yeah, there's another problem. Even if you crouch, we actually move slower in midair for some reason. So let's try to make a new speed property for air. And it's gonna be the same as walking or running, should I say. So if grounded, then speed is speed air, and if if we're not grounded, because well, now we have a problem. We can't. With this, we won't be able to crouch in midair, which is unfortunate. But oh well. And the jumping is really high, way too high. So let's divide it by 2. Oh, that's just pathetic. No. Come on. Whoa. Oh, okay. Okay, I forgot about this. That's one of the problems with physics. That's it. There is a problem and if you don't define a physics material, by default it uses a built-in physics material, which has friction. So we're gonna make a special physics material that doesn't have friction at all, and it's gonna be, I think, maximum. I think, and we're gonna use that for our collider right here. So now if we if we jump... Nope, I needed to set it to minimum. Now if we jump, you can see that everything works just fine. Almost. We also probably don't want the player to be moving too much when it's jumping, so if we release our keys, you don't stop mid-air. Well, there are many ways to fix this, but one of those... for now we'll do it like this. We'll just make it so that if we're grounded, then velocity is this and that. But if not, velocity is body velocity. So it will just use its natural velocity, and it won't be affected by all with your input. So now if we jump, we can't actually control ourselves, which is not too good. But whoa. But at least we don't stop midair when we jump. A nice way to do things would be to just have some kind of damping variable that would change depending on your state. And yeah, what else could I possibly make for this? Okay, let's make it so that I ask you questions. What would you want to see? Sorry, what? Oh, yeah, sure. I actually totally forgot that we have a box. You can totally move the box. It's just that now your character is frictionless, and because of that, some objects, if there would be objects jumping on top of you, for example, falling on top of you, they would actually fall down from your head. They wouldn't be sticking to anything, which is, I guess that's okay, but maybe that's not what you want. So perhaps you would want a different approach to how you make your character. Anyone else has questions? No? No? Yep. Yeah. Because... okay, so let's say our character doesn't have interpolation, so if we pause the game and run it, if we press... Actually, no. Let's make the time scale really small, like 0.2. Then if we unpause the game, you can see that every single frame like the camera doesn't actually fall down smoothly with this when the game is like slowed down. It like skips some frames or something. But that's not because the game is lagging. It's because the physics object itself only updates itself a certain amount of frame. But to fix that, you would use interpolation, and with the interpolation, again, it would just interpolate the movement of things. So now you actually see that we move like smoothly. Versus like that. So you can see the difference. Well, if you would land, well, actually maybe you don't actually see this now, but if you would land, there would be actually a frame where you would be like inside of the ground, perhaps. Or if you would land, it wouldn't feel like a solid landing. It would feel like you're smoothly stopping at the ground because of the interpolation. But one way to fix problems like this would be to just use use a time step that is optimized for the frame rate that you want to use. So, for example, if we oh, come on. So let's use a calculator. It's a big ass calculator. Let's divide 1 by 60. You get this value, and then if we would use that here, I think that's for 60 FPS, but it might not work just exactly the same way. Well, it kind of works better now, I think. But the thing is, once you change the time step, you need to readjust your physics, because, for example, if you have a very small time scale, you would have to maybe up your physics forces and whatnot, because things are moving with a bit more precision, I suppose. So when you're making things like this, you definitely need to tweak it a lot. Any more questions? No? No? Oh well. Anyway, guess that's it for now, or a break or something.
Hello everybody,